Hello viewers, in this video I will discuss about the term entropy. Okay, we will see what is the entropy and what are the properties and characteristics of entropy, and we'll see what is the value of entropy for different process. Okay, for a reversible and irreversible process. Okay, we'll see what is entropy. So this entropy is measure of randomness or disorder of molecules of a system. Okay, so see that it is a measure of randomness of the molecules. Okay, the randomness means nothing but see that it means that not in a pattern. That means you don't have any fixed pattern. That means randomness. Okay, the molecules are moving in a random manner. It does not move in any pattern. Okay, so that measure, so the measurement of the randomness of the molecules. If you see that the molecules gain some energy and it will move in a random manner. Okay, imagine a situation like this. So let us see, some people are sitting around a round table. Some people are sitting in a round table in a garden or somewhere. Suddenly a snake arrives. Suddenly a snake arrives near them. So what could be the reaction of all the people? So they will be moving, they will be scattering in all the directions randomly in some other. They will be that's running like that. Okay, they do not follow any logic. They do not follow a standard pathway. Okay, they will be moving somewhere randomly like that. See, the molecules will move randomly like that. So more randomness gives us high value of entropy. So here we see that there is no more randomness. So here rho entropy. Okay, so how we are getting this randomness? For example, see that. So see, I am heating this. So for just for your purpose of understanding, I am burning this thermocol. You can see that the movement of like for your understanding, see the movement. This is in a random manner. If I giving heat, see the randomness. Okay, see somewhat the movement is very randomness. So the molecules are moving in a very random manner. Just for your understanding, I have taken this. Okay, so like that, when you give heat or when you observe heat, there is a change of entropy. Okay, for example, another example. So when you compress this sponge, okay, when you compress the sponge or when you expand the sponge, see that there is the molecules are moving in very random manner. So there is some change of entropy. Okay, so some of the examples to show to understand the term of entropy. So now, so you know that entropy is a measure of randomness. Then entropy is another point we have. Entropy is a property of a system. It is a property. Okay, so to show in a mathematical manner, here we can see that see, I am writing here delta S because the notation of entropy is S. So delta S is equal to delta Q by T. So what it means that see here delta S, it means there is change in entropy which is equal to change of heat by absolute temperature. So this equation is taken for where the temperature is constant or absolute value of temperature is taken. Okay, so here we see that we have only change of entropy. We do not mention anywhere as absolute value of entropy. Only there is change of entropy. This is change of entropy means that final value minus initial value. It represents final value minus initial value. Because here this entropy is a state function. It is a state function. It does not depend, see, it does not depend on the path. It depends only on the initial and final values. It does not depend on the path. It is a state function. So we do not mention absolute value of entropy, only the change in entropy. Only here, see that this only change in entropy. Okay, so for temperature is called constant. So what happens when there is a variation of temperature? So in that cases, we can write it as integration of ds, which is that is of the limits. So which is equal to integration of heat by temperature. So this value is delta S. So this value of delta S is equal to integration of dq by t. So we have the integration of these values dq by t for different values of temperatures, that will give you the change in entropy, where here this is not constant, temperature is not constant. So we have two formulas for finding the change in entropy. Okay, so another point to be added, this entropy is an extensive property, that is, it depends on mass. Okay, it's extensive property. So now we'll see what is the units of entropy. So you know that delta S is equal to delta Q by T. So from this, I can say the unit of entropy is either joules per kg Kelvin, because it depends on mass. So joules per kg Kelvin or calories per gram degree Celsius or Kelvin, depends upon it. In terms of mole, it could be written as joules per mole Kelvin or calories per mole degree Celsius. So these are the units of your entropy. Okay. So please make a note of it. Units of entropy and some points about entropy. Okay. So then some characteristics of entropy. So we have some characteristics of entropy. So what is that? So first point we have, when heat is supplied, whether temperature changes or not. See whether temperature changes or not. In some situation, whether when ice melting to water, see that when there is a change of latent heat, when there is latent heat of fusion or latent heat of melting. So here we see that there is only latent heat, there is no change of temperature. Okay, so in such cases, see that whether there is a temperature change or not. Okay, so when heat is supplied at that condition, we see that the change in entropy is positive. Okay, or we can say that delta S is greater than 0. So let us consider example like this. So I want water in liquid to convert into gas. So here heat is being supplied. Okay, so in such a cases we see that there is a increase in your entropy. Then value of change in entropy will be of positive value. Okay, second point. So when heat is rejected, so like what I have said, ice melting to, water converting to ice. Okay, so when heat is rejected, whether temperature change or remains same, whether temperature changes or not. Okay, whether the temperature changes or not, whatever the condition, when heat is rejected, the change in entropy will be negative. It is rejected, or the value of will be less than 0. So in this process, liquid to solid, that is ice, water converting into ice. So here the heat is rejected, in which it is converted into ice. So there is a decrease in entropy, that value is less than 0. Then we have another point. For an adiabatic process, where the change of heat is 0, so in such cases we see that the change of entropy is also 0, because the initial value of entropy, final value of entropy are same. So the change of entropy will be 0 for an adiabatic process. So these are some of the characteristics of entropy. Okay. Next we see for an isolated system. So entropy of an isolated system. So what is isolated system? You see there is no transfer of energy and matter. So there is no transfer of energy, no transfer of matter. So that system we call as isolated system. In such case of isolated system, what is the change of entropy? So let us take a system like this, an arrangement like this. We have a wall here, so we have A and B, gas A and gas B. So let us take gas A and here gas B. So it is totally insulated outside. So see that it is insulated outside, insulated. Okay, so there is no transfer of any heat inside or outside. Okay, so now when I release this wall, what happens? There will be random movement of the molecule. So there will be random movement. Okay, so here we see that red will be combined here and blue A will be combined in this B. So random. So there will be more randomness of the molecules will be available here. So here the change of entropy will be always greater than or equal to 0 for an isolated system. Okay, so now we consider this universe as an isolated system. So the change of entropy of your universe is always greater than or equal to 0. So what is this universe? This universe consists of system, surrounding. This is universe. So system plus surrounding is the universe. So delta S of universe will be, what is this delta S of universe? Nothing but the summation of delta S of system plus delta S of surrounding. Okay, so this is about your delta S of universe, system plus surrounding. So we will see the values or the total value of the change of entropy for a reversible and an irreversible process. So what is for a reversible process? So reversible, let us take it as an isothermal or adiabatic process. So I will consider a isothermal process. So in isothermal process, so under reversible, I am taking an isothermal process in which in case of isothermal process, we know that temperature is constant. So what happens to the change of entropy for a system? So let us now take it as heat transfer. Let us take a process of heat transfer. That is heat rejected. Heat is rejected to the surroundings. Let us take such a situation. Okay, not heat supplied, heat is rejected. In such case, you see that the change of entropy in system will be minus dq by t because heat is rejected outwards. So in the system there will be negative heat. So minus dq by t. Okay, so what is the change of entropy in your surroundings? That will be equal to plus dq by t. As heat is rejected outside, there will be addition of heat. Okay, see the temperature remains constant because it is isothermal process, temperature remains constant. So what is the entropy total? Total will be minus dq by t plus dq by t. So delta S total will be equal to 0. Okay, 0. So it means that delta S of reversible process will be equal to 0. The change of entropy for reversible process is equal to 0. Okay, so now we will see what is this for an irreversible process. Okay, so irreversible. So same case of heat transfer. We'll take it as a heat transfer outside. Let us say the case of heat transfer outside. So let us take the temperature of system as T1, the outside temperature as T2. So as heat is transferred, see the temperature inside will be more when compared to outside. So heat is transferred. So now what is the temperature change in entropy of the system will be minus dq by T as heat is transferred, or T1, because inside the system the temperature is T1. So of the surroundings will be dq by T2. So what is the in total? So total will be minus dq. Let us take minus dq as common. So it will be 1 by T1, or dq as common. So minus 1 by T1 plus 1 by T2. So from this we can say that it be the delta S of total will be greater than 0, or the delta S for irreversible process is greater than 0. So for totally the delta S of your universe is always greater than or equal to 0. So it means that delta S of universe is equal to 0 for a reversible process, greater than 0 for a irreversible process. Okay, but naturally we can say all process, naturally I can write it above. So naturally all process are irreversible. So entropy changes increasing always. Okay, is increasing always or increasing continuously. Okay, so this is the end statement of your entropy for a reversible irreversible process. So this is the statements of irreversible irreversible process, and we've also discussed about the various properties and various characteristics of entropy in this video. Okay, so I am sure that it will be useful for everyone. Okay, thank you.